In this video, we're going to talk about how to write functions using function notation. So linear equations are functions. And remember that we can write the equation of a line in slope-intercept form. Slope-intercept form is y equals mx plus b, where m, the coefficient of x, is the slope, and b, the constant term, is the y-intercept. So let's look at this a little more closely. So the slope, remember, is the rate of change of the linear function. If you're looking at an equation in y equals mx plus b, the slope is going to be the value of m. M is also described to be the rise over run. And I like to think of this as the change in y over the change in x. So let's look at this graph and talk about how you can figure out the slope of the line. So it's always a good idea to pick 2 points that have coordinates that are integers. So just doing that is going to make it a little bit easier for us to count and figure out the slope. And when you're also figuring out the slope, you want to work from left to right. So I'm going to go from P to Q, and I'm going to draw out a path that's going to tell me how to get from P to Q. So this path is going to go over 1, 2, 3, 4, 5. So I'm going to go to the right 5, and then I go up 1, 2, 3, 4. So up 4. So when I'm describing the slope, if I go to the right, that is a positive number. If I'm going up, that is a positive number. Because the sign of the number is going to tell you the direction that you're moving in. So when I describe the slope, which is m of this function, remember I'm going to do change in y over change in x. So I'm going to say this is up 4 over 5. Okay, so that means that my slope is 4 over 5. So what about the y-intercept? The y-intercept is the point where the graph crosses the y-axis. You can also think about this as an intersection point. The y-intercept is where the graph intersects the y-axis. The y-coordinate of the y-intercept will be the value of b, and y equals mx plus b. So let's look at this graph and figure out the y-intercept of this line. Notice that it crosses the y-axis at -5. So that'll be the point 0, -5. So that y-coordinate, -5, is going to be the value of b if we were going to write an equation. We would use b equals -5. So let's write an equation for this linear function and use function notation. So you can see here we have a graph of a line, and we're going to write an equation for it. So the line, remember, has an equation y equals mx plus b. We need to figure out the values of m and b in order to be able to write the equation of the line. So first I'm going to work on figuring out the value of m. So to figure out the value of m, you need 2 points to figure out the slope of a line. My graph here has 3 points labeled, but you can pick any 2 of them that you would like. So I'm going to pick these 2. I'm going to pick 3, 3, and 6, 1. And then I'm going to draw my path going from left to right between these 2 points. So from 3, 3, I go 1, 2, down 2, and then I go right 1, 2, 3. So down 2, right 3. When you're counting slope, if you go down, that will be a negative number. If you go right, that will be a positive number. Remember, slope is change in y over change in x. So when I write my slope, m will equal -2 over 3. Now we need to figure out the value of b. b is going to be the y-intercept. So you can see here at 0, 5, that is where my graph crosses the y-axis. So b equals 5. Now I can just plug these 2 numbers into my equation, and I will get y equals -2 over 3x plus 5. So I have the equation of the line, but they also want me to use function notation. So notice that this line is a function, right? All linear equations are functions. So instead of writing y, I can write f of x, and I would have f of x equals -2/3 x plus 5. And that is my equation of the line in function notation. So sometimes we can be asked to find slope without being given a graph. Remember, the slope is the rate of change, and it is m in y equals mx plus b. So if we're not given a graph, we have to use this formula right here. This y2 minus y1 over x2 minus x1. And x1 and y1 are the coordinates of the first point on a line. x2 and y2 are the coordinates of a second point on the line. Remember, you only need 2 points to determine the slope of a line. So let's try using this formula with an example. What is the slope of the line through -2, 7, and 3, -3? So what you do is you're going to label your points. Remember, each point is an xy value. So if I call this first point x1, the second that goes with it has to be y1. Okay, x1 and y1 stay together. And then the second point, this is going to be x2 and y2. So now I have my values that I can plug into this formula, y2 minus y1 over x2 minus x1. So for y2, I'm going to use -3. Then I have minus from my formula, and then 7 is equal to y1. And that's over x2, which is 3, minus from my formula, and then -2. Okay, be careful with those negative signs along with the subtraction and make sure that you're keeping up with them. If it's a negative number in the original coordinate, make sure that you have that negative when you write it in the equation. So now let's simplify this. We have -3 minus 7, which is -10. In the denominator, we have 3 minus -2. Well, remember that minus and negative will become a plus. So this is -10 over 5. And we can simplify this. -10 over 5 equals -2. So m equals -2, and that is the slope. So let's try writing an equation for this function, and let's use function notation. So remember, the equation of the function is going to be in y equals mx plus b form. So we need to figure out the value of m, which is the slope, and the value of b, which is the y-coordinate of the y-intercept. So let's first start with slope. So for slope, we're going to need that formula, y2 minus y1 over x2 minus x1. So when you're counting the slope, you can pick any 2 points that you want on the line. So I'm just going to pick these 2 points because they come first. So remember that t has taken the place of x and g of t has taken the place of y. So here I'm going to label this first point. I'm going to call that x1, and this y point is going to be y1. 0, 2, I'm going to call this x2, and then this is going to be y2. So now I'm going to plug into my formula with the values that I've labeled. So I have y2, which is 2, minus y1, which is 1, over x2, which is 0, minus x1, which is -1. So now let's simplify this. 2 minus 1 is 1. And then I have 0 minus -1. That minus negative is once again going to become plus. 0 plus 1 is 1. 1 divided by 1 is just 1. So my slope, which is m, equals 1. Now let's think about how to find the y-intercept. Well, the y-intercept, if you think about it, it's an xy point, right? The point where my graph crosses the y-axis is always going to have an x-coordinate of 0. So 0, y is going to be the y-intercept. Because if we think about it, if we look at our graph, remember that every point that's a y-intercept will be on the y-axis. Well, everywhere along the y-axis, all of these points have an x-coordinate of 0. So that's why my y-intercept is going to be the point where my x value equals 0. Well, if I look at this table, I can pretty quickly see where the y-intercept is, right? See, this point is where my x value, or my input value, equals 0, so that will be my y-intercept. So my b value is actually going to be 2. So I can plug into y equals mx plus b, so I have y equals 1x plus 2, which is the same thing as saying y equals x plus 2. In this equation, instead of x and y, they use t and g of t. So you can just plug that in and substitute in this formula. So we would have g of t equals t plus 2. Okay, so all I did is replace the y with g of t for function notation, and then the x is already being used as t, so I just replaced that x with a t. So remember that you can write equations of lines using function notation. You're just going to have to first write the equation in y equals mx plus b form, and then figure out the values of m and b.